This video should reacquaint you with polynomial functions using the class notes and example sheet for section 11.2. So let's get started. So we're going to start here by looking at an example of a polynomial. And this one's rather long. It's got about 7 terms, I think. But hopefully you notice that it's just made up of a bunch of power functions, right? That we're either adding or subtracting together. And that's basically it. But I will also point out that you'll notice all the exponents on the variables are whole numbers. Even this one right here, where it's just a 2, right? We could rewrite that term as plus 2x to the 0 power, right? So 0 is a whole number, so that fits. I will also point out that there's really no restrictions on what the numbers in front of the variables, which we call coefficients. There's really no restriction on what kind of numbers those could be, right? We have fractions, we have irrational numbers with pi and root 7. That is not a problem, okay? So let's write this in here. What is a polynomial? It is a sum of power functions for which each exponent is a whole number. All right, so using that definition, see if you can figure out which of these are or are not polynomials. Unlike the last sheet, it's not like all of them are or all of them are not. Why don't you pause the video and do that right now. All right, thank you. Let's see what you got. If you said that numbers 3 and 6 were not, but everything else was, then you got it right. I think with number 1, there's not really much to argue about here. This, by the way, since it's got 3 terms, is called a trinomial. Over in number 2, we have a binomial, and we're good here. You know, as long as that square root, right, isn't on the x, then we do have a whole number exponent. We do run into trouble with number 3, right, because we've got that x cubed in the bottom. That term, right, if we wrote it in power form function, would be 3 times x to the negative 3, and negative 3 is not a whole number, so that is not polynomial. And with number 4, you might have thought that maybe it's not a polynomial, but I think we were saying before that, you know, we could write this term as 2x to the 0. Now, some students will say, yeah, but poly means many, and there's only one term. This is a monomial, but it still can be thought of as a polynomial. If you want another term, here I'll write one, 2x to the 0 plus 0x squared. How about that? All right, and let's see, with number 5 down here, flipping that fraction over that we had up there, that kind of makes things okay, right? We could rewrite that term, that first term, as 1/3 x cubed, and we still got power function with whole number exponent. But over here in number 6, right, little problem with this last term, the minus 3x to the 1/2, that is a problem. So not a whole number. As we move along here and take a look at the general form of a polynomial, it looks scary at first, but it's really, if you just look at it carefully, it's just adding up power functions, okay? We're using these little subscripts to just help us to note that this number a sub n minus 1 is different from this number a sub n, okay? And the idea is that n is the highest exponent, the largest exponent we have, and then we go down by 1. When we do that, this is called writing it in standard form, which we'll mention a little later. And so, you know, n might be a 5, so there'd be x to the 5th term power function, and then there might be an x to the 4th. There might not be. A sub n minus 1 might be 0, okay? And then we might have an x cubed term, and then we can get to an x squared, x to the 1st, and so forth. Of course, any of these a's could be 0, so we might not have an x squared term in them. This last one here, you'll notice, is a sub 0 times x to the 0, but x to the 0, of course, is just 1, so that's why we could rewrite it without an x on it. All right, so some terms that we have are as follows. We have what's called the degree of a polynomial, okay? So the degree of a polynomial is the largest exponent, All right, I'm going to write that. It's the largest exponent. And so in our general example here, the degree would just be n, okay, because that would be the largest exponent in our general form. So we might call this an nth degree polynomial. You know, sometimes we'll say it's a fifth degree, fourth degree. That tells us what the largest exponent is. The terms I've written out, the terms are just each one of these power functions. So just writing them out. The coefficients now, those are simply the numbers that are multiplying each variable, right? So we would have a sub n, and then a sub n minus 1, and then a sub n minus 2, all the way down to a sub 2, a sub 1, and then I guess we could call a sub 0 a coefficient. It is multiplying x to the 0, but it also has a special name, as we will see. Yes, indeed, a sub 0 is, of course, what's called the constant term, right? It's the one term where the variable does not necessarily show up, okay? Now, the leading term, that is always the highest degree term, okay? A lot of times that's the term we write first, but it doesn't have to be, but it is the highest degree term. Okay, so in our example, our general example, it would be a sub n times x to the nth power. And it's a very important term, because, as we will see later, because it does dictate what happens for large values of our polynomial. So this is one reason we're paying a lot of attention to power functions, what their graphs look like. The constant term is also kind of important. We'll see pretty much, if you think about it, if you plug 0 in to your polynomial, all these other terms will become 0, and you'll just be left with your constant term. And that means that the constant term is the y-intercept, right, of your polynomial. All right, and then the last thing we mention is when we get a polynomial in standard form, that means we align the terms from highest degree to lowest degree. And so, the way we have it written here is this is in standard form. So having covered that, why don't you do some of this to the polynomial we started with. Why don't you first write it in standard form, okay, and then state what the degree is and what the leading term is for our polynomial f up here. Pause the video and do that. Okay, thank you for doing that. See if this is what you got. All right, so one thing you want to keep in mind when you rewrite or write a polynomial is making sure that the sign stays with the term that follows it, right? So I got a positive that stays with the 12x cubed, the negative stays with the 1/2 x to the 8th, so we have negative 1/2 x to the 8th, right? And then the minus here stays with the root 7 x to the 6th. Looks like most of the rest of them are positive, but they're going down in degree. Now, if you really wanted to, you could put in those 0. You could have in here, because we don't have the x to the 7th term, we could say plus 0x to the 7th, but there really is no need to do that. When you skip over terms like that, that's fine. Okay, it's this is an 8th degree. I didn't ask for how many terms, but it's an 8th degree 7-term polynomial. All right, and the leading term is negative 1/2 x to the 8th. And as you'll see in the next part that we look at, this leading term is going to play a big role in our knowledge of the polynomial.